We live on a big blue marble hurtling through space at 90 miles per hour, and this marble has a solid core, a hot, gooey middle, and a rocky outer layer. And the craziest part of all, it's not even a single piece. It's made up of 7 giant, irregularly shaped puzzle pieces that constantly shift and change over time. And these puzzle pieces are called tectonic plates. Earth is the only planet in the solar system we know of that has these giant moving slabs of rock. So how do they work? How do they move? And why don't they just snap together like a jigsaw? That's what we'll explore today. This is Earth. And just like a giant cracked eggshell, our planet's outer layer isn't a single solid piece, but instead about a dozen major slabs of rock called tectonic plates. These plates are so large that a person or even an elephant is completely insignificant in comparison. They range in size from the small Pacific plate, which is roughly the same size as the United States, to the enormous Eurasian plate, which spans almost 1/3 of Earth's surface. Together, these plates cover the entire planet and are always on the move. Now, the fact that the Earth's outer layer isn't one solid piece is actually pretty surprising. You see, deep inside the planet, the temperatures reach over 9,000 degrees Fahrenheit, which is hot enough to melt rock and metal. And this extreme heat creates a thick liquid layer of iron and nickel called the outer core. This churning liquid layer acts kind of like a giant magnet, generating electric currents and magnetic fields that extend all the way to the Earth's surface. And this magnetic field protects us from harmful radiation in space. But what's really crazy is that the super-hot liquid core actually makes the Earth's crust behave like a giant cracked eggshell. Even though the crust is mostly solid rock, it's dotted with giant cracks called faults. These faults allow the crust to be broken up into several dozen irregularly shaped pieces that can move around like rafts floating on a sea of magma. But wait a second. If these plates are floating on a sea of hot magma, shouldn't they just sink like a stone dropped in water? Well, no, because despite being a liquid, magma behaves very differently than water. Magma is so thick that it practically doesn't flow at all. In fact, even though it's technically a liquid, geologists refer to it as a very viscous or thick paste. This means that although magma can slowly ooze and bubble up through the cracks in the Earth's crust, it won't pull these plates down into the planet like water. And thanks to this unique property of magma, Earth's tectonic plates are free to float and move around. But how do they move? The answer might surprise you. You see, even though magma is basically a thick paste, it still moves in predictable ways. Deep within the planet, magma is pushed upward by the heat from the Earth's core. And as magma rises through the cracks in the Earth's crust, it cools and hardens, creating pockets of cooler and denser rock. And this process is called upwelling. As magma continues to bubble up, these newly formed pockets of dense rock pile up along mid-ocean ridges, where the seafloor spreads out like a cracked eggshell. And here's the cool part. As new magma pushes older rock away from the center of the ridge, it drags the tectonic plate with it. And this means that tectonic plates can travel across the globe at a rate of up to 4 inches per year. That's fast enough for a snail to crawl across the continental United States in a single lifetime. The continuous creation of new seafloor at mid-ocean ridges is also what drives the recycling of old seafloor back into the planet. You see, even though magma is thick and doesn't flow easily, it's still denser than the solid rock around it. And this means that as magma pushes up against cooler rock, it can actually force the older rock downward, melting it and turning it back into magma. This process is called subduction. In fact, most of the Earth's oldest seafloor is recycled back into the planet every 200 million years or so. And this helps keep our planet in balance by preventing it from getting too heavy or too light. But even though magma is responsible for creating and destroying seafloor, it's not the only force at play. Gravity also plays a big role in shaping Earth's surface. You see, even though Earth's gravity pulls everything toward its center, it also pulls tectonic plates around in different directions. For example, as new seafloor is created at mid-ocean ridges, the excess rock piles up and spreads out. This buildup of rock causes the seafloor to bulge upward, and the added weight of the seafloor causes Earth's gravity to pull the plate downward. This process is called subsidence, and as a result, many ocean basins are actually slightly deeper at their centers than at their edges. For example, the Puerto Rico Trench in the Atlantic Ocean is nearly 8,000 feet deeper at its center than at its edges. And this happens because the weight of the thick seafloor in the middle pulls the plate downward. And here's the crazy thing. Gravity doesn't just affect the seafloor, it also affects the continents. You see, even though continents look solid and unchanging, they're actually made up of layers of rock of varying densities. And this means that the continents can slowly sink into the Earth like a pebble dropped in water. For example, the Eurasian plate is gradually sinking into the planet near the Java Trench in Indonesia. And this is happening because the denser oceanic crust of the Pacific plate is pushing the lighter continental crust of the Eurasian plate downward. And this process is known as flexure. And as a result, Earth's continents aren't as sharp and well-defined as they appear. Instead, they're actually rounded and smooth, much like a river-worn pebble. But even though magma, seafloor spreading and gravity play a huge role in shaping Earth's surface, they're not the only forces at work. In fact, Earth's atmosphere also plays a big role in driving plate tectonics. You see, even though it's invisible, Earth's atmosphere is made up of several layers of gas, and each layer has a different effect on our planet. For example, the lowest layer, called the troposphere, contains most of the planet's water vapor, and this water vapor can cause clouds and rain. And as these water droplets accumulate on Earth's surface, they add weight to the continents. And this extra weight causes the continents to sink even further into the planet. And this process is known as loading. For example, during the Ice Age, much of North America was covered in thick sheets of ice and snow. This added so much weight to the continent that it caused the land to sink as much as 400 feet. And even though the ice sheets have melted since then, the land hasn't bounced back up yet. And scientists think it could take thousands of years for the North American plate to stop sinking. But despite the forces that bring them together, Earth's tectonic plates don't actually fit together very well. There's so much friction between the moving plates that they often get stuck, and this can cause the plates to build up stress and energy. And when the stress becomes too great, the rocks along the fault lines suddenly slip, and this releases energy in the form of earthquakes. In fact, many of Earth's most powerful earthquakes happen along the edges of tectonic plates. For example, the 2011 Tohoku earthquake in Japan had a magnitude of 9.0, and it released enough energy to power the United States for 26 years. And this is because the Pacific plate was suddenly thrust upward as it collided with the Philippine Sea plate. But while earthquakes can be devastating, they're also essential for life on Earth. You see, even though Earth's tectonic plates move apart at mid-ocean ridges, they also collide with each other, and when they do, one plate is usually pushed beneath the other, and this process of subduction recycles old sea floor back into the planet. And here's the crazy thing. The heat and pressure deep within the planet turn the rock into some of the most valuable minerals on Earth, like gold, silver, and copper. And this is why many of the world's largest mineral deposits are found in areas where tectonic plates collide. For example, the famous Witwatersrand Basin in South Africa is one of the largest gold deposits on Earth, and it formed when the ancient Kapval Craton collided with the Zimbabwe Craton. So even though tectonic plates constantly shift and change over time, they're essential for life on Earth. You see, the heat and pressure deep within the planet create the perfect conditions for generating minerals that we use every day. And this means that even though Earth's tectonic plates may seem like a giant puzzle, they're actually more like a well-oiled machine that keeps our planet running smoothly. But even though Earth's tectonic plates are essential for life, they can also be incredibly dangerous. You see, the San Andreas Fault in California is one of the most active fault lines on Earth, and it runs for over 800 miles through some of the most densely populated areas of the United States. And this means that a major earthquake along the San Andreas Fault could cause catastrophic damage to cities like Los Angeles and San Francisco. That's why scientists are constantly monitoring the San Andreas Fault for signs of an impending earthquake. And this incredible fault line is just one of many places where Earth's tectonic plates are constantly pushing against each other. In fact, there are dozens of fault lines and earthquake zones around the globe that are home to some of the most powerful earthquakes in history. For example, the 1556 Shaanxi earthquake in China had a magnitude of 8.2, and it's estimated to be the deadliest earthquake in human history. And this is because the Eurasian plate was suddenly thrust downward as it collided with the Indian plate. But even though earthquakes can be terrifying, they're also an essential part of our planet's natural cycle. You see, even though Earth's tectonic plates may seem like a giant puzzle, they're actually more like a well-oiled machine that keeps our planet running smoothly. And this means that even though Earth's tectonic plates may seem dangerous, they're actually essential for life as we know it. Thanks for watching. If you like this video, check out my latest video on the unbelievable journey of Puff the Magic Dragon, or check out my series exploring the strange and fascinating world of magnets.